Since opening its doors a decade ago, the Canadian light source synchrotron has paved the way for world-class research, innovation, and development. But it hasn't always happened within these walls, and sometimes the CLS itself is the beneficiary of advancements made.
This by far is the most complicated machine that we've ever built for them. A lot of very, very tight tolerances, stuff that we had to bring in very specialized laser measuring equipment for, machining at constant temperature, so it really made us raise the game.
The piece of equipment Jim Boyer describes is an elliptical polarizing undulator, which will become part of an experimental station that utilizes both high and low energy to analyze a wide variety of materials.
We can look at things like semiconductors or car batteries. The X-rays are not very powerful. They don't go very deep, so it's all surface science. It's looking at the surface of it, or the electrons on the surface of materials.
The synchrotron already has 2 EPU units, but this one is much bigger. In fact, it's the largest of its kind in the world, containing 1,560 rare earth magnets, which are used to manipulate the beam lines.
So the forces that we're dealing with can be incredibly strong. Each one of the magnets has probably about 70 or 80 pounds of pull or force on it. So that's why the superstructure had to be so big, robust, and rigid to support those forces.
The project was so complicated it required 1 year to complete, as it contains 1,100 separate parts, 865 of which had to be manufactured. But building it was just part of the challenge. It had to be shipped at a constant temperature of 24 degrees Celsius, even though it was minus 33 outside on the day it was brought into the facility.
If you start stretching, things are cooling off. Steel and aluminum, they will move, and you won't get them back to where they were.
The good news is it wasn't a far trip for the EPU, as it was manufactured in Saskatoon by RMD Engineering. The firm worked closely with synchrotron employees to build the unit, which in turn has helped build the international reputation of RMD.
Inside of this, and then they're doweled and screwed so that there is zero movement.
Well, having it in Saskatchewan it's just a very cool thing. We have somebody that's in-house. This isn't the first project RMD has done for this light source, and hopefully it won't be the last. Bringing that know-how to Saskatchewan is very exciting.
We know we're very fortunate that they come to us, because they could be going to Germany or Japan, but because this is the only one of its kind in existence that's this large, it really puts us on a playing field with everybody else.
CLS officials will now spend the next 6 to 8 months installing and adjusting the magnets before the EPU is put to use. From the Canadian Light Source Synchrotron, I'm Simon Hyatt reporting.